Okay, so I want to take a few minutes to go over how to get the correct answers for the homework assignment that you had for the last class period. So we're going to need a couple of things. We're going to need the homework assignment itself, which is the predicting solubility as a salt assignment. It was in its own worksheet packet, so there's that. And then you're going to probably want your periodic table out, and you're also going to probably want to have your notes out if necessary. Your periodic table might also look something like this on the front side, which we will talk about and discuss shortly. But I just want to make sure that we have all of the tools that we need to get us to find success here. So we're going to start by focusing on this compound only, because the first 4 or 5 problems you were given the reactants, and you were given the reactant states of matter, which were aqueous and aqueous. And remember, aqueous means that those substances have been dissolved in water. Now, the next thing that you need to know is that you were given CUS, and you were not told what its state of matter was. So the way that I go through and I try to determine what the state of matter is by the use of these solubility rules right here. Now, these solubility rules are really, really helpful if you follow along and just kind of apply them the same way. So I'm going to try to figure out which solubility rule best applies to CUS by going through these solubility rules one at a time. Rule number one says all compounds of group 1 metals like lithium and sodium and potassium, or LiKNa, are soluble. Well, lithium, sodium, potassium are not here, so we're going to go on to rule number 2. Rule number 2 says nitrates, NO3, acetates, C2H3O2, and chlorates, ClO3, are soluble, and those are not present over here at all. Okay, so we're going to come back and focus on this. So then we go to chlorides. Rule number 3, all chlorides, Cl, bromides, Br, and iodides, I, are soluble, and those aren't present here either. So we're going to move on to rule number 4. Sulfates, SO4, also not present over here. So we're going to move on to 5. Compounds that have carbonate, chromate, hydroxide, phosphate, sulfite are, and then there's not present here. So we're going to go down to rule number 6. All sulfides, S, are insoluble. Oh, here's my sulfide. Here's S. It's right here. So that means that this is an insoluble substance, which means it makes a solid. So this compound, CUS, forms a solid because of rule number 6. So now that we figured out what that solid is, now we're going to go back and really only focus on HCl at this point, which I've already told you clearly is aqueous, because that's the answer key says, but again, I want to show you why. So I go back to the beginning. I start with rule number 1. Rule number 1 says all compounds of group 1 metals like lithium, sodium, potassium are soluble. Well, hydrogen is it's in group 1. Take a look, see, it's right here. It's in group 1, but it's technically not a metal. But it's also behaves like a metal sometimes, so we might apply that rule there. I'm going to go on to rule number 3. All nitrates, NO3, acetates, C2H3O2, and chlorates, none of those are present in this structure here. So now we go on to rule number 3. All chlorides, Cl, bromides, Br, and iodides, I. Look, here's chloride, here's Cl right here. So that tells me that rule number 3 probably has to apply here. So let's read the whole rule. It says all chlorides, bromides, and iodides with metals are soluble except if they're with silver Ag, mercury Hg, or lead Pb. And since Hg, Pb, or Ag are not present over here, that means it's soluble, which means it's aqueous. And this compound right here is aqueous because of rule number 3. The other part that I added that you did not necessarily have to add was the idea that whether or not the reaction occurred. And this reaction occurs because a solid forms. So now I'm going to go ahead and do another one with you, and then we'll just kind of talk about the rules going forward. So here we have again sodium hydroxide reacting with hydrogen chlorate to produce sodium chlorate as a product and hydrogen hydroxide as a product. I've given you the reactant and its state of matter, and I've given you the reactant and the other reactant and its state of matter. So now we're going to really only focus on this compound here, NaClO3. So I'm going to go back to my solubility rules, and I'm going to try to identify which solubility rule applies. So I start with rule number 1. all compounds with group 1 metals like lithium, Li, sodium, Na, or K, or potassium, K. Well, look, sodium is present here, so that tells me that this rule, rule number 1, probably applies to that compound. It says all group 1 metals are soluble. So that means that if they're all soluble, that means group 1 rule 1 tells me that this is an aqueous compound. But then I also, just to kind of like really make sure of myself, I went down and I looked at rule number 2 when I focused on ClO3. So this says all nitrates, NO3, all acetates, C2H3O2, and all chlorates, ClO3. Look, there that is again, are soluble or dissolvable. So that tells me that this is aqueous. So this compound is aqueous because of rule number 1 and or rule number 2. Now, I need to go back and look at HOH here. HOH is another way to write water. And so if I, oh no, hold on. And you, nope. HOH is another way to write water. And if I look down here, and I realize this is kind of like tinier to see, but if I look down here, there is a rule, like I can read through all these rules, but I'm going to kind of skip ahead, and this doesn't really show up very often, is that when H2O or HOH is present as a product in a double replacement reaction, the reaction occurs. So really this rule, because water is formed and it's a liquid as a product, it forces the reaction to occur because of rule number 9. This is one that we won't do very often, and I think I kind of should have probably not included it in this particular worksheet, but in reality, that is a rule that works. Now let's do this last one, and then we'll kind of talk through the next 3. Okay, so calcium chloride reacts with potassium carbonate to produce potassium chloride and calcium carbonate. So here we have CaCl2, I tell you it's aqueous. Here we have K2CO3, which is potassium carbonate, also aqueous. Potassium chloride has KCl. So I'm going to start with rule number 1. All compounds of group 1 metals like lithium, Li, potassium, or sodium, Na, or potassium are soluble. Well, K is present here, so and it's soluble, and because of rule number 1, it's soluble, so that means that this has to be aqueous. If I wanted to continue on and just kind of focus on Cl over here, we could do that. We could go and say, look at rule number 2, all nitrates, NO3, acetates, C2H3O2, or chlorates, ClO3, are soluble. Well, that rule doesn't apply, so I'm going to look at rule number 3. All chlorides, Cl, well, look, there it is, right there. And what does it say? With metals are soluble, except if it's with mercury, silver, and lead. And potassium is not mercury, silver, or lead. So rule number 3 also makes KCl aqueous. Calcium carbonate. I'm just going to start reading again at the top of the rules. We're going to focus on CaCO3, and we're going to start reading. All compounds of group 1 metals, Li, lithium, sodium, Na, potassium, K, are soluble. Calcium is not one of those, so we're going to go on to rule number 2. All nitrates, NO3, not present. All acetates, C2H3O2, not present. All chlorates, ClO3, not present. I'm going to go on to rule number 3. All chlorides, Cl, nope. Bromides, Br, nope. Iodides, I, nope. So we're going to move on to rule number 4. All sulfates, SO4, nope, not quite. Now we're going to move on to rule number 5. All compounds with carbonate, CO3, chromate, CrO4, hydroxide, OH, phosphate, PO4, or sulfite are insoluble. Yes, carbonate is here. CO3 is this one right here, and carbonate is right here. And then what it says is that they are insoluble except if they're with group 1 metal. Well, if I go back and I look at this particular guy right here, calcium is in my second column, so it's not a group 1 metal. So this makes this my solid because of rule number 5. So CaCO3 is a solid because of rule number 5. I'm not going to go through the rest of these in as great of detail, but I'm going to point out that if you look at rule number 5 for PbOH2, you'll see that hydroxide is the reason why rule number 5 works here. And if you look at number 1, all group 1 metals, there's potassium right here. That makes that aqueous because of rule number 1. Question number 5, you have AgCl and H2S as products. So AgCl, I tell you that it's rule number 3, so I go look at rule number 3. It says all chlorides, bromides, and iodides are soluble except if there was silver. Look, Silver's present, Ag, so that makes this a solid because of rule number 3. H2S applies to rule number 6. All sulfides are insoluble except if they're with group 1 metals. And if I go back and I look at this here, hydrogen is a nonmetal that behaves like a group 1 metal, so we'll say that that's aqueous right there because of rule number 6. So this is a brief video that is designed to work through the first 5. We'll have a short video for the rest of these, the rest of the section here, and then we'll wrap this up and you can move on to your assignment for the day.